Hello and welcome to Pool School, brought to you by Memphis Pool. It's my privilege and pleasure to be here to spend a little time to go through, a few things that'll make you operating your pool a whole lot easier. And the chemistry is something that really befuddles and confuses more people than anything else. The rest is purely mechanical, and that's what we're going to focus on today is strictly chemistry. And we're not going to get into a lot of things. We're just going to, basically, there are three things that we're going to talk about. And as we go through these three things, just think of it in terms of more or less like we're building a three-legged stool. And if once you understand these three legs, these things that make up the three legs, and you've got the seat, and that's where you can build more and more knowledge on that, because these are the three essential elements that you have to really have a good grip of to understand how everything works and interplays. Because a lot of, I've made the analogy before, a lot of this is sort of like a plate of spaghetti. You pull one piece and the whole thing moves. Well, that's what it has. We're going to talk to you about how to keep it stable and how to really get it work and fit together. So that's what the whole thing is about today. It's about chemistry. Okay, and as I said, we're going to talk about three things, and these are going to be the three things. The first thing is something that people are always more interested, that actually is a preliminary thing, is the sanitation. Keep it safe, keep it healthy, and that sort of thing. But that's probably, but then there's some things that work around that, and we're going to talk about those things, and that's the reason I put sanitation number one, because that's the first thing people will always talk about is sanitation. Okay, so let's look a little bit closer at that. And in talking about sanitation, we always get involved in chlorine, because it is a very good sanitizer. It's the most widely used sanitizer in swimming pool water, water parks, whatever you have, recreational water, water treatment, cooling towers, all kinds of things. You're going to find chlorine is a real, very, very common thing. And this is just the chemical symbol for it, is just Cl for chlorine. A second element you'll hear about a lot of times on treating the water is bromine. These both belong to the same chemical family. They're halogens along with iodine and some other things. But you don't find bromine used as much in pools as you do in spas. Warm water does well, but you could treat pools with it, but it's a little bit pricier to do that, and you don't, it's not really, like I said, it's a pretty pricey way to treat a big body of water. Okay, so, and I would suspect that most of you use that. Now, that's not to say that you couldn't have something to supplement it. For example, a lot of people will have ozone. Ozone is an incredibly effective germicidal agent, but it doesn't last long. It's very environmentally friendly. It's made out of oxygen. It works and does a bang-up job, and you don't use as much chlorine, but that's another point. Let's just stick with the subject here, is chlorine. And chlorine in the water is found in the form of hypochlorous acid, and bromine would be in the form of hypobromous acid. That's how it works. Now, I hear a lot of people from time to time talk about, oh, my brother-in-law and his wife got my sister and brother-in-law have a new pool, and they don't use chlorine. They use salt, But you don't just dump salt in there and do the same thing. Matter of fact, we've written an equation or two here, and you can look at it and see that basically you have salt is sodium chloride, and then once you put it in the water and you dissolve it, then actually you form this hypochlorous acid. That's what you do. Now, you don't just dump it in there and it does it all on its own, but rather there's a cell. And this cell, as you can see by the threaded parts and the fittings, is a part of the system. And as the water goes through there, there's a low voltage current delivered to it, and there's some electric plates in there that take this hypochlorite, that convert the salt, the chlorine that's in the salt to hypochlorous acid, and you have sodium left over, which is reflected at the end of the equation. And then so we don't lose sight of what happens with the sodium forms sodium hydroxide plus the water. This is what you have here. But basically all of this stuff works pretty much, this is just a side reaction. This is the main thing right here. But as I said, you have to have a salt system to do that. You don't just dump it in there. But notice the main point I want to make is that it makes hypochlorous acid, the same thing as when you have tablets, granules, or actually even bleach you can put in the pool, and it forms hypochlorous acid. Okay, now one of the big things that people will say a lot of times, oh, I don't like the chlorine because of the smell. It's the smell. Well, one of our ladies is artistic bent, and she's put this smell symbol here, and here's the pool, and this is supposed to represent this awful odor. Well, guess what? The chlorine doesn't have an odor to it. Well, yes, if you take a tank of nothing but chlorine and it ruptures or something, you would have that. But what you're smelling from a pool, recreational water, anything else, it's not the chlorine, but rather it's some products that are comprised of that. And here's what happens. The main culprit in this whole thing is nitrogen, one of the essential elements. Living things and products of living things are made of amino acids. And these amino acids all contain this nitrogen. And so what happens is when you have nitrogenous material in the water in the form of perspiration, body byproducts, or excrement, or anything like that, the chlorine that's in there attacks these nitrogenous materials and break them down. And this diminishing thing is supposed to show what happens if you have enough chlorine. Well, it drives that reaction on out to the end, and you have some nitrogen salts or gases off or something like that. It's not there. That is if you have enough chlorine. If you don't have enough chlorine, this reaction stops somewhere along here, and that's the intermediate products here are the chloramines. This is what you have. You have this is what's doing the smelling, and the more of this stuff that accumulates, the stronger the smell of chloramines. And that's why a lot of times when you get your water tested, they'll ask you to shock it, and this is basically that's what you're doing, is you're running that reaction on out to the end. So remember, it's not the chlorine that you're smelling, but it's the lack of having enough chlorine to get rid of this nitrogenous material. And that's what the whole thing is all about, is having enough chlorine. So you don't smell it because it's too much, you smell it because you don't have enough. Okay, point number 2 that we had on our list, remember we had 3 things. One is sanitation, and the second has to do with pH. And the pH just basically has to do with how acid or how alkaline the water is, and it's always represented on a scale of 0 up to about 14, and these are derived by logarithms and things. And as I say, a lot of times I remind our people, said, look, what we're talking about here may not be scientifically perfect, correct, and the use, but basically we're just talking about, we're trying to build some knowledge around it, not to work into the minor details of the thing, but to give you an overall view. So when you have, where this comes from has to do with how much of the acidity is there as it's measured, and then we have this midpoint of that's neutral, and that's when you have the correct amount, or I'll say that's when you have an equal part of the hydrogen and the hydroxyl ions that are formed within the water. And guess what? This is H and an H there. You got 2 H's and an O, so you have H2O. So what is that? That's water, and it's perfectly neutral. It's neither acid nor alkaline. And it's important because if the chemicals that you're adding to the water make it acid, well, it's not good for the pool structure. It's not good for the plaster, the vinyl liner. It's not good for you. Now you say, well, let's just throw a lot of alkalinity in there and run it on up, and we don't have to worry about it. Well, there's a problem with that too. And here's, this is going to show you what's going on there once you shift that around, all right? So basically what we have here is the same pH scale we were looking at. We show it down very low here. And you see we have 6.5, 7, 7.2, 7.5, and on up that way. This is the pH scale across here. Now, the chlorine will exist in 2 forms in the pool. It's hypochlorous acid, which is what I told you is the active form that does it. And then as the pH increases in this whole reaction here, as the pH increases, the hypochlorous acid is becoming dissociates it now I say pull apart, it doesn't pull per se, but it's coming apart. You always have 100 amount of the chlorine. If you look at this, here's the amount of hypochlorous acid, 91%, and you'll have 9% of the hypochlorite ion. Now this ion will have it, but we want to worry, we will have to watch what we do here as we move through the pH, because the hypochlorite ion is not effective at all. Well, I shouldn't say not at all, but it's not nearly as effective as the hypochlorous acid is. So what we're trying to do is to keep the pH, the acidity and the alkalinity in balance so that we have it at some kind of an ideal point on the scale down here, so that we're not too high. We're not in the acid range down here, but we're not so high that we've got all of our chlorine in the form of hypochlorite ion, but we want to have as much of the hypochlorous acid as we can. That's why they always say, and different people will try to strive for different things. Some of them will say between 7.2 to 7.5 or something like that, but regardless, you have to stay in a perfect world. If we could put it on 7 and keep it there, that would be great. That'd be ideal. You'd have 76% of your chlorine in the form of hypochlorous acid and 24%, the weak form of chlorine, if you will, in the form of the hypochlorite ion. But it's not a perfect world. So all it takes is just a little bit of a shift to push it this way, which reduces the amount of hypochlorous acid and converts it to the hypochlorite ion. And if you go the other direction, go below 7, then what you've got there is you go below 7 on the pH scale, then here again you've got acidic water, which is not good either. So the pH is important to keep the chlorine in the proper killing form, the most effective, which is the hypochlorous acid. That's why we have that's why the pH is important. That was point number 2. Point 1, remember, had to do with sanitation. Now for the sanitizer, which is chlorine, to work, you have to keep the pH in this right range. That's what's going on there. Okay, now having explained or hopefully clarified this thing about the hypochlorous acid and where the pH has to be and that sort of thing, then how do we work the rest of it? Well, the other thing that has to do, then we have to adjust the pH. And to adjust the pH, it's very simple. You either raise it or lower it depending on what you have. If you're using one form of chlorine, like for example, if all you do is throw in granular chlorine all the time, you're going to be raising the pH. So you want to lower it, and you understand why you want to lower it. You don't want it getting too high, because here again you have a lot of that hypochlorite ion. You'll always have the chlorine there unless it's gone. But anyway, to lower it, you'll use muriatic acid or some other approved products. There's a granular form that does it, and a lot of people are going to that and like that because of the muriatic acid, which is liquid, can splatter, and a little bit, you can be a little bit sensitive about operating with that. Or then if the pH is low, these 3-inch tablets that a lot of us use, they're big like hockey pucks, you put those in your chlorinator, maybe in your skimmer basket. Well, as those tablets dissolve, they will lower the pH. And so sometime you're going to want to raise the pH. Here again, you don't want to get down on the acid side and stay there, because it's not good on you and it's not good on the pool. You want it in as low as it can be, but you want it in the range where it's not going to hurt you or the pool, but it'll still be effective. So you can raise it with sodium carbonate, and that's usually in the form of, we have a common name for sodium carbonate is soda ash, but you'll see it on the market as pH up, pH increaser, or something along that line. Okay, all right, so that takes care of pH. Now, the third point, remember point number 1, getting back to it, I just want to make sure you understand we got these 3 legs of the stool. We've got sanitation, we have pH, and then we have the alkalinity. Now the alkalinity is important because it basically is a, the pH, excuse me, John, okay, you have to chop it up, I'm sorry.
It's okay. Now the alkalinity.
Alkalinity basically is for...
3, 2...
All right, now alkalinity, a lot of people confuse that with pH or something like that, but the alkalinity actually is the common name in the scientific field. It's used as a buffer, and what that does is helps stabilize the pH. For example, if you don't have enough alkalinity in the water, And what this represents here, look at the alkalinity. Now look, this is just makes a point. This is a pictorial illustration. But the alkalinity doesn't necessarily hang down like this, but if you've got enough alkalinity in the water, then you see as you got more and more, the pH is going up. So you want to get this one stable place here. Now in the case of the greater Memphis area, we have very low alkalinity. Matter of fact, we're very fortunate because our water is very, very good. It doesn't have, there's a lot of stuff missing that you would find in other cities that have hard water overridden with hardness and calcium and a whole lot of other things. So we are fortunate in that all we really have to do is add enough alkalinity to our water from time to time to keep it so that once we get this pH set, we can kind of keep it there. But if you're living in another place here again that has real high alkalinity, hard water and that sort of thing, you want to lower it. So it can be adjusted, but in this greater Memphis area, at least on this aquifer here, we're going to find we have low alkalinity and we just add it and put it in there, and then we won't have any trouble at all keeping that pH where we need to keep it, in that range that we need to keep it. And remember, the whole point, to say it for the 15th time, the whole point of keeping that pH in that range is to keep the chlorine in the most lethal form that you can have with regards to killing microorganisms. So in adjusting the alkalinity, and here's where we are in our part of the world, we're always trying to raise it. We use sodium bicarbonate to raise it up and put it up, and it's a very straightforward formula. You use so much for every 10,000 gallons of water, for depending on how much it's off. You do a little quick calculation, you can see you need to add 5 pounds, 10, 20, or whatever the case happens to be. But remember, when you're adding water, municipal water, and it's raining, I promise you this, the alkalinity is going down. But if you ever get in a situation where you need to lower it, you miscalculated or somebody did something silly or you moved to another part of the country, you're wanting to lower it, and you'll use muriatic acid or here again some other approved product. Okay, that's point number 3. Now to review what we did, we said we had 3 things. We wanted to talk about sanitation, and we got into chlorine, pH, because that determines the form that the chlorine is in, and the alkalinity. You see the alkalinity was tied onto the pH and helped that. So we have them listed here, A, B, C, but we've discussed this. I could take this and flip it over. We discussed this in the reverse order of this, but the first order of business to get your water balanced is get the alkalinity fixed. Get the alkalinity fixed, and then once you have that, then you can get the pH set, and it'll behave itself. And then once you have that pH in that right range, then you can get the maximum sanitary power out of your chlorine that's in there, because with that proper pH, you're keeping that chlorine in the form, the hypochlorous acid form, that you need. They have to work together like that. So basically, it's like I said, once you understand this, now there's a lot more to this chemistry and the chemical balance. There's a calcium hardness, temperature, there's a whole range of things. But these are basically the first 3 things. Once you understand this, and everything else kind of builds and works together to get perfect balance all the way around. Thank you again for spending the time with us. And if we can help you in any way, we're always here. And if you have questions and comments or something, you can go to the Memphis Pool YouTube channel or our Facebook page. And we appreciate any comments, any way we can help you. Memphis Pool is a very old company, locally owned, operated, and all the business you do benefits people in this area. Thank you.